Hello and welcome to the third episode of Remote Pair Programming. I'm Adi Bolboaca, a programmer, trainer and coach at MosaicWorks, and I have with me
Michel Daviot. I'm also a programmer, a coach. I used to be a software architect, and I work more and more as an agile coach.
and today we'll try to do strong style pairing or remote. I don't yet know the problem, so we'll see what I will be faced with. This is the challenge. Basically, try to do remote strong style pairing without knowing exactly or anything about the problem. So,
So I introduce the problem.
yes, please.
So it's something I discovered during a session I did in Lyon a few weeks ago. And the idea is we have a scientist who puts ants, these small creatures, on a
Mm-hmm.
stick. We know the length of the stick. We know where the ants start with. And we know that when the ants move forward, they can either collide with another ant. In this case, each ant will turn backwards and start walking in the other direction, or they can reach the end of the stick, in which case they fall. And the goal of the exercise is, given a starting situation with a collection of ants and the length of the stick, when does the last ant fall?
Okay, so we have these sticks, right? This is where they
You have only one stick, huh? Only
only
one
one.
stick.
Okay, so only one
Yes.
stick, but you have more ants.
Yes.
Okay, so you have more ants, and the stick can vary in the length.
Yeah. For one call to the solver, we have a set length of a stick.
Okay, so it's set. And the ants can start from any
Anywhere.
part of the stick. And then which is the question? We want to know where they end, when they end.
How long does it take for
How
the
long?
last ant to fall from the stick?
The last ant. Okay.
Yes.
And we do know the number of ants.
Yeah, you know the number of ants, the position, and which direction do they face? Are they facing left or are they facing right?
So the position, um, and the velocity.
Yes, you can. This is not really defined in the initial problem.
Mm-hmm.
You can assume that all ants have the same velocity, but the problem is more interesting if you have the velocity as input parameters. Yes, and the velocity is constant.
Mm-hmm. Okay. So basically, here, what I am usually doing, I try to analyze this in terms of inputs and outputs from the outside of
Mm-hmm.
the system.
Mm-hmm.
So the if and I try to have some types of outputs. So some real examples. The
Mm-hmm.
outputs
Yeah.
in this case would be maybe the simplest possible game like that would be that I have a stick with one ant.
The simplest is you have a stick with no ants,
Uh,
and and then the output is 0.
yeah, exactly. That's the simplest. With where basically you know the output is it's fixed. You don't need to treat anything.
Mm-hmm.
Um, but I was going a bit further. So if I have a stick with one ant facing right, or let's say, and then facing left. So I try to do this thing of introducing only one notion at a time. If I don't introduce ants, as you said, with zero ants, I don't care about the ants. I just care about the stick, and basically, and I don't know about position. I don't know about anything else. So with zero ants, that's for sure. If I have only one ant, then and the direction, then I introduce two things: the the direction and the ant, the concept of ant.
Mm-hmm.
and then I introduce the other direction, left, let's say. So I want to look a bit at the inputs. For 0, if I have this output where it's 0, the that you said you want to know when, so that's a time, right?
Yes.
That's the output. So the output would be 0 seconds, let's say, and this is in the case when I have 0 ends. So that's probably the first test I'd write.
Mm-hmm.
And I try to do to think about maybe 2 or 3 or not more than 7 anyway. And the next one would be I have 1 and
Do you want me to start
facing
implementing
right.
the test you just mentioned while you think about the next step?
Yeah, typically I take a bit of time just to think about 2 or 3 and then I go on. But I think we can go. So let's try some strong style. So I'll be more or less explaining what to do and you'll be typing. That's what strong style is. So let's just define the output first. Assert the assert that at the output, yeah, it should be 0, and the input should be, yeah, and then we need to give it the number of ends. So define value as the number of ends as 0, and now we need to use the ends count in some way to determine that, because now we're not using ends count. So let's just say time is ends count. Yeah, alright, let's do this. And solver. And then we'll just return 0 from that function. Okay. It's red.
Okay.
Let's make it pass. Great. And solver should okay, the next step then should be something like it should check that time is 1, or no, let's do it another way. Let's say time is 0 for a for one end and a 0 length stick. I don't know about facing. I don't care because it's a 0 length stick. So in this way I introduce only one concept, and that's the end.
Okay. The thing is, yes, this makes me do something. Okay.
So it's to be the same. I have the end count is no, that's 1. That's 1. And the time should be again 0. So in this way I'm kind of triangulating on this method. Yeah. So you're adding another method.
Yes. Do it like that.
Okay.
Okay.
Okay, so now let's see, the next method is check that time is 1 for an ant on, and now we need to understand a bit the length. How do we define length? One length.
Mm-hmm.
So for an ant on a stick with length 1, do we care about facing?
I think so, because
I don't care about facing if it's from one side, so if it's on the edge of that stick. So if it's
okay.
the same length, I shouldn't care if it's towards left or towards right, as long as I put the position on the edge. So in this way I'm introducing position. So I would say check time is 1 for an ant on a stick with length 1 at position 0.
Okay. So how do you want me to model an ant?
Let's see, I don't really care now. It's just 1. So I wouldn't model an ant now. I would just say that when I have one ant and the stick length is 1, then I would return a 1 in the test.
Okay, so I don't specify the position.
No. Or
okay.
Yeah, that's better.
So this is the test.
Yeah.
Time is 1 for an ant on a stick with length 1. Okay,
but
so
the time should be 1, not 0.
1.
Yeah.
Yes. Here it's. Here I can use the stick length to make it green.
Great. The next step, one of the options would be to try to introduce position, the thing that we didn't do last time. Or another thing we could do is go on with length, so triangulate more on length. So I would try to do that, maybe try to go more on length, and in this way we would be able to introduce velocity, right? If you have length more than 1, let's say 2, then I would need to compute the time depending on the velocity of the ant.
Okay. So the velocity would be maybe 2.
Yeah. So then we'll have 1 again. Is the result. And that's a very good test.
Excuse me?
That's a very good test, I said. Okay.
So it should be red initially. Yeah, that's good, because it introduced the idea of time is equal to distance divided by speed.
Yep. So could we extract that into a function called something like velocity, or at least to a method? That, yeah.
Compute time based on distance
and speed. Mm-hmm. Great. Now we have, I think, a lot of duplication around here in these methods. Now I would approach this in two ways. One would be to try to merge the methods. The other one would be just to go on with tests. Merging these would mean that I need to change to do small refactorings and then to also add to the tests the values they don't have, like the end speed, for example, that doesn't exist in the first test, or the length that doesn't exist in the first test as well. So yeah, let's try to go on a bit. I'm just saying there are options. There are always options like that. So let's try to go on, and I guess now if we'll say the time is 1.5, let's try to do that. So just try to triangulate, but on a smaller scale. That time is 1.5 for an ant with velocity 2 on a stick of the 3, yeah. And this should pass immediately. This should pass immediately without doing anything.
No, because the types are wrong. The types are wrong.
Okay, let's see.
This one passed because I'm using ints at the moment.
Oh, so the types, yes. Great. Yeah. So this is a very small step test. In fact, it's good.
So the speed, I will make it a float. I will return a float here.
So we understood that the types are wrong.
The stick length should be a float also.
Great. Okay. Yeah, of course, because it's float. Don't you have I didn't use Scala for a long time. Isn't there something to compare floats in the...
Yeah, that's what I was trying to do.
Because there's something that says something like assert, something like equals...
What I'm trying to set up here, writing the way, but there's a proper way. Yeah, that's good. I'm saying it should be equal more or less
with that error of
delta, some epsilon. Yeah.
What is it? 10,000? Yeah, I don't know. It's a kind of very small error, right?
Yeah.
Okay. Now let's go on like that and see if we have the time. I think on this path we don't have a lot of things to do.
I could see working with position.
Yeah, exactly. So I would introduce position, and let's try to position the... So let's have the first test. Check that the time is 1 for an ant with velocity 2 on a stick with length 2. Yeah, and position 1. Let's say 1. And the length, it should be 2, not 3. Let's try to use the simpler. We have ants count 1.
No, this is wrong. This is wrong. Our velocity is 1, but velocity is 1 by default. So here time is 0.5, right?
Because we
only have one unit to move forward.
Yes.
Speed 2 on position is 1. Position.
Okay.
by default, we assumed it was 0 initially, so only
Yeah.
the last test should fail. Okay. And now what I'm going to do is I'm going to do something like that.
Okay.
I will try to refactor that
So
because
that's,
this is the distance to go.
yeah, that's the distance. I would extract that as a function as well. As compute
You want a
distance.
method for that?
Yeah, compute distance, like the like compute time.
Let's be consistent. Okay.
Okay. So tests are good.
Green.
We introduced the position as well. Should That's a question for you, the business owner. Is there a can the position be float, or it's just integer?
Yeah, it can be float, but I already managed it in the implementation.
Yeah, but we don't have a
I
test.
used, yeah.
That's what
So
I'm
shall
saying.
I update this test or create a new one?
No, I'll create a new one.
Okay. Time and position 1.5 and
So if
velocity
it's
1.
1.5, that's 0.
Position.
Yeah.
Float.
And this should pass directly, right?
Yeah. Yep. Good.
Okay. We have one ant with one stick with one position with position. Now let's introduce direction.
Yeah. So we start with a 0.
Yes. The time
1, 0. Facing left.
Well, if the time is 0, oh, you mean, yeah. So we put the ant at the end of the stick, and I would start if I have a stick of length 1. Let's try to do that. I have a stick of length 1 and velocity, I don't care. Because I put it at the end of the stick. So it is facing left, and the position is 1 as well.
Okay. So time will be 1.
No, time is 0. Because I have a length 1, and I put it at position 1. So then time is 0. I basically place the ant where it will immediately fall down the stick.
Okay, but this we already tested, I think. Huh?
Yeah, but we introduced the position without without changing too much of the code.
Okay, I will follow you.
Yeah. So check that the time is 0.
Okay.
For an ant with velocity.
Okay.
Okay, 1 maybe.
So
facing right, let's say.
Facing right. Okay, understand.
And position 1 on length on a stick with length 1.
Okay.
Position 1 should be.
Yes.
Yeah. Thanks.
Okay. So how do you want me to say to this method that we are facing right?
I think we just tell it the position, like, although we say not the position, the
Excuse me?
direction. just give it either a string or an enum or something like that that says right.
Can it be a simple boolean? Face is right, or you prefer an enum?
I would prefer it to be named to have it
Okay,
clear.
understand. Okay,
So
so here I would say right like
yeah,
that,
that's
and
better.
somehow I need to say it's right. Okay.
Mm.
Okay, let's do that. So I will have to say the trait direction,
Mm-hmm.
make object right, left.
Well, we don't need left yet.
You're right. And here I will just add the direction.
We have the direction, which would be left.
And by default, it will be
Alright,
right, so we
whatever.
don't break anything.
Mm-hmm.
And it should be enough.
Let's run the tests. Mm-hmm. So it says
0 was not 1. Time is 0. Okay.
yeah, it should be 0 velocity. Yeah. Mm-hmm.
I guess next step will be facing left.
Yeah. Alright, so now let's introduce left. And facing left, the time should be 1. Also changing the in the name of the test. Into the it says facing right now, so
Time is
check that time is 1 for an end velocity 1 facing left.
You're right.
Yeah, great.
Okay, so now I need to do something with this direction to make it pass.
So it's not enough just to have the length. We also need to know we have the position, but we also need to know where it is situated, the direction. Yeah, so
I think I will do this in this method.
don't you can't you just change signature or something? Like if you do that and you
Signature.
I'm not renaming.
Signature.
And just add there the direction. Direction. Yeah. Alright. Weird. It should have changed it there as well. Yeah. Okay.
And here what I will do is if we'll do it with a match. Match is so by default this is what we had, and now going left I think I will do stick length
Is the other way around.
It's just on position, I think. I have to go from the position to 0 if I face left.
Yeah, okay.
Okay.
Great. Okay, so let's see now if let's make things more complicated. The time is 1.5 for an end with velocity 1, facing left. Let's put a stick like a stick I know 5. And that means if it's facing left, I need a computer. I'm tired. What should be the position? So if it's 5, we want the velocity 1. That's 3.5.
So it should be 2.5, yes. length is 5. Velocity is still 1, 2.5. I expect it to pass on the first try.
Yeah, so that would mean we're on a good path.
Yeah.
Okay. So I think let's add another one, even though we'll maybe duplicate a bit the test for the right, because we just have one test for facing right.
So something I noticed for the moment is that we are doing strictly nothing with the ants count. Huh?
Yeah, exactly.
So I would like to do some refactoring and remove this ants count everywhere.
Well, I don't know. Probably the next step would be to use it. So after adding the thing with the right, another test with the right, I would triangulate on the ends count. So just leave it be. Just one more test. I know it can be annoying. So just let's see. Check the time is 2.5 for an ant with velocity 2 facing right. And where should it be? If it's position to, let's say position 2, and let's have the length float as well, right? That means 2.5 velocity. Oh, that's complicated. Yeah, let's simplify it a bit. So just let the time be 2. So check the time is 2 for an ant with velocity 2 facing right and position 2 on a stick of length. That's 4, right?
6.
Oh yeah, it's 6 because you're doing 2.
Right.
Aha. We found something.
I know, because here and left when I run the test. Yeah, test is passing.
Yeah, alright. Great. So now let's go on with the with
Working
number
with
of
more
ants.
ants.
Yes. So let's have 2 ants.
So just here I take the business hat. Each ant will have a different speed and position and initial direction, right?
Yeah.
Okay.
So let's have 2 ants. Let's see how we'll change completely the code.
Okay. So here the time is.
So we need to have the time for each one.
Whatever.
Of the ants.
I want the time for each one. Okay.
No. So if we have 2 ants, let's say 1 and 2. I don't know.
Maybe.
Oh, you're meaning that both have the same velocity and the same facing left.
Position.
1 and 2. Or 0 and 1. Yeah, 0 and 1. Okay, that's fine.
Okay, and something like that. So the time would be.
It's 3 and 2. Okay. So now we need to have we have the stick length that wouldn't vary, but now we'll need to have a generalization from having a value to having a collection of ants, and each ant will have its own speed and position.
Okay. So we could have ants is a collection of ant which would have velocity equals 1, turns equals left, position equals 0, and maybe that's enough to start with, because here I have something which doesn't compile. Cont1 equals this. Try to make this compile.
Yeah, okay. Yeah,
Okay
so,
with that?
yeah, so let's create the ant.
Make a case class ant action speed. So this almost compiles. So now I will say ant1 and I want a second ant. So the speed is the same, direction is the same, but position is different. Two ants. With that, I mean wrong.
Okay, so now the ant count. Yeah, so now the ant count will become a count of
Yeah, it's the size of my list. I'm
this.
not
Yeah,
sure I
so
will need.
just say and just use the count. Yeah, for now, and then need the length.
And I expect the times to be a list of 3 and 2. This is going to be tricky to test.
Because probably you need. Yeah,
Times
you need
the
to compare
0
it
should
to.
be and times the 1. Is it okay with that?
Yeah, but should be 2, not 3, the second one.
Yeah, you're right.
Great.
Okay, so I need to create this method. So here I have ants, which is a list of ant, and I have a stick length, which is a float, and I will return, I think that's what we expected, 3 and 2. This should pass. Probably because it needs to be float, and I will add this.
Found. It's 1, but should be 3. Okay, great. So we just tricked it, right? Let's
so
just have another one. Um, just change something, whatever. I don't know. Put 4 and 2 for 2 ends
4 and
with.
2 will be.
Sorry?
Okay, go ahead.
I said 4 and 2. Yeah, I'm just
Okay.
trying out things. So 2 ends, the same velocity, facing left, positions 1 and 0, 1 and 2.
Isn't it 2 and 0 positions?
2 and 0 on a stick of length 4, right? Is it?
It's 0 and 2 then.
Yeah, it's 0 and 2. Yeah, but I have the velocity 1. Yeah, that's good. Yeah.
4 and times should be 4 and 2.
So let's triangulate on this.
Okay, so here I need to actually do something. What's the quickest way to do it? I will do something like that.
Can we reuse the unsolver from the?
Yeah, that's what I want to do.
Mm-hmm.
So it's position, direction, speed. Yield, solve, 0, stick length, speed, position, direction. Hope this will do it. And again, we see that the ounce count is completely useless.
Yeah.
Because I just hard-coded it. Ooh, 0 is not.
0 is not 3 plus or minus.
Didn't expect that. Stick length, speed, position, direction. Oh, that's surprising. Its position, direction, speed. But here it's not facing left, it's facing right.
We
Should be
set
facing
left.
right.
So our.
If we are at position 0, 0 facing left, we fall immediately, so we have time 0.
Yeah, it's right. For both tests.
I think here it's the same, huh?
Yeah. So sometimes tests can be wrong as well.
Yeah. Yes, and this works.
Great. Let's see another test. What could we do?
So now we.
Or
okay,
no,
go ahead.
No. Let's just refactor. Let's do a lot of refactoring. Let's remove the count that we saw it's useless, and I thought it would be useful, but it's not.
Okay.
So the ends count, just need to change signature, remove it, and remove from all the tests.
Can move it from here. Okay.
Now let's go back to the production code. And let's see the first ones, the first methods. Or is this everything? Is
Here
this
we
all
have
the code? Oh, that's all the code. Okay. We compute the time. We compute the distance to go. Okay. Is there anything else?
I'm quite happy with the code at the moment.
Yeah, I was looking at the types a bit, but everything is float, so it's fine. We did write tests with float for everything. So let's see if they collide. What should happen if they collide?
They go. Each one goes the other direction.
Okay, so let's have a stick with two ends. We have they start. We have a stick with length 2. And they have a speed 1, okay. But one is at position 0, one is at position 2. The first one goes from... No, the first one goes from left to right, yeah, and the second one from right to left. They should collide in the middle, and then they should go back. So then the time should be 2.
Yeah.
Because
Both
no,
times
3.
should be...
Or no, they go to the center and then they go back. So it should be 2 for both of them.
Yeah.
So let's run this.
Yeah, this is already passing.
Wow, amazing. Good job.
It's because they have the same speed.
Yeah. So now let's...
So they are equivalent.
Let's say check that ants collide when they have with the same speed, or when they have the same speed, something like that. And now let's say you have a stick of 4.
The next one is when we have different speed.
Yeah, different speed. We have a stick of length 4. The first has speed 1, the second has speed 2. The first one starts from 0. The second starts at 4. So they will reach...
I suggest we use 3. It will be easier to compute.
Yeah, it's true. Yeah, so that then the... Oh, from the position from 3, you mean? Or the length 3.
Whatever.
Yeah, we
especially the position. Because they will collide at position 1 this way.
Yes, exactly. Now they collide at position 1. So the first ant goes to position 1 and back. That means it has 2 at the time. The second one goes... makes 1 towards left. They collide, and another one towards right, and then 0.5. So it's 2.5, right? Does it make sense?
No. 2.5.
Because it's 4 the length.
Yeah, because it's 4. You're right. Yeah, and this should not pass.
Yeah.
Yeah. 4 was not 2. Okay. Even this one doesn't pass. Which is okay, which is normal.
Yeah.
Because it didn't take into account that they collided.
Yeah, so now I think we should implement the speed, right? Or take care about the speed from the end solver.
Okay, so here I'm supposed to detect the collision, and how could I do that?
The collision happens...
I'm not comfortable making this test pass in one go.
It's too big?
I think it's too big. I think I will need to detect the when the collision appears, and iterate on each collision, to compute the time.
So then we need a smaller test. Or a simpler test.
Yeah.
What can that be? Can that be when they collide? When they collide at one end? Can that be of help?
They cannot collide at one end.
Yeah, because of velocity. So if one has velocity 1 and the other one has velocity 2...
They only collide when they are going different directions. Huh?
Oh, okay. So they only collide when they have different directions. Then... simpler test. I don't know. If we
What I have in mind is that I need to compute what happens just before the collision.
So just before the collision, that means you need to know their position so that they could go back.
At the moment of the collision.
They could change the direction. So basically, we need to have a kind of way to compute when they change direction. That's what the test should be about.
Mm-hmm.
The test should be about the fact that we need to simulate that one of the ends will change direction when it collides with another one.
Both will change direction, yes.
Yeah, but we could assert only one of them because that's a simpler way.
Okay.
And how can we do that? We have a speed. If we keep the speed the same, would that pass? Let's try that. So if we keep the speed 1 for both of them,
I'd like to suggest something. We had in mind to switch at some time. Maybe it's a good time to switch now. And I guide you on the implementation because I have an idea on the next steps of the implementation.
Okay, let's try to do that. It will take a while, probably.
I will just comment that out.
Yeah, and do a push on.
Yeah.
Okay.
Okay, you should be able to recover it. Do you want to stop the recording while we switch and you share your screen?
Yeah, I'll stop the recording now.